So all the carries are only depending on C1. You can see C2 depends on C1, C3 only depends on C1. Similarly, C4 also depends on C1. So what the change is that we have to apply some more hardware. Hello students, today we are going to learn about this carry look ahead adder. Okay, so in the last lecture we did learn about how a half adder and a full adder works. In case you have not checked out that, then you must first go through that. Okay, so over here I will give you the brief and then I will tell you that what is carry look ahead adder. Okay, so in the last lecture we did learn that how a full adder is developed. In case you want to add two binary numbers, suppose a number A 1111 and a number B 1010 like this from right to left. Okay, and this green box is there, so which I am considering. So in which there is a carry which is to be added to number A. Okay, and then further to number B, and then ultimately this is the output and this is the carry for the next two digits toward left. Okay, so how the addition takes place, suppose C in is the carry to the numbers A and B. So first of all, C in is added to A, so C in plus A, suppose the output is X. Okay, so that X is added to number B, which gives the final output. Over here it is 1, so we can see that when 1 is added to 1, so the answer will be 0 and there will be a carry 1, and that 0 when added to 1 it will give 1 like this. Okay, now when the two numbers are added, C in carry in plus A, then this SOR gate is actually adding the two numbers, but the carry is developed when both are 1, means C in is 1 and as well as A is 1. So when both are 1, then the carry is developed 1, so therefore we have to input to the NAND gate, means carry developed by this operation C in plus A. Okay, similarly the output X is added to number B, so that is giving output Y. So one more SOR gate, whatever the output X is added to B, so one more SOR gate, and this addition can also develop some carry. Okay, so the X and B are input to a two input NAND gate, because when X and B are one, then only carry will be developed. Okay, so out of these two, only one will develop carry, either C in plus A will develop carry or X plus B will develop carry. So either this or this, so through an OR gate, so get the final out carry. This is the in carry, this is the out carry. So this we have already learned, just I have refreshed a little. Now remember this thing that the same circuit can also be developed like this. Means either I input the C in over here and B over here, or B over here, C in to this circuit. These are two equivalent circuits. In most of the books it is given that A and B are added to this circuit, and this is the output, and C in is added to the second circuit. But in case you go through mathematical processing, both are same circuits. Okay, now what is a look ahead carry adder? See what happens that when the two numbers are added, it is developing carry, then that carry is added, ultimately one more carry like this, then that carry is added, again the carry. So what happens, the formation of carries 1 2 3 4, that takes some time, so it renders to delay of addition of two numbers, because until and unless the carry for next addition is developed, no addition can take place. Okay, so serial fashion, the carry is developed, first carry is developed by these two numbers, then these two numbers like this. So in a serial fashion, C1 C2 C3 and C4 are developed. Okay, so look ahead carry adder is developed to make the addition faster. Okay, however the circuit needs to be updated with more number of components, means the process of this, that look ahead carry adder is developed so that addition can take place faster, and more number of components are required, of course, so it can increase the cost of equipment. However, faster addition will take place. The principle of look ahead carry adder is that all the carries depends on only first carry generated, means only on C1, that I will show you how. Okay, so all the carries are developed simultaneously and added to the numbers respectively, so it saves the time. Instead of serial wise fashion, means C1 develop with C2 develop, it's not like that. Simultaneously all the carries are developed and added to the numbers, so it saves the time. So I think you all know that what is the mathematical boolean expression for the boolean operations. For example, when A and B are connected by the help of SOR gate, means A and B are the input giving the output Y. Okay, then it is written as A, the symbol of SOR gate is plus and a circle is there, and B. Similarly, in case A is ANDed with B, means A and B are input to some AND gate, then the mathematical expression is output Y is equals to A dot B, A into B. Okay, And in case A is connected to B by the help of some OR gate, then mathematical expression is y equals to A plus B. This you might be knowing. Okay. Now we will learn that how this carry look ahead adder works. Okay, suppose there are two binary numbers who have digits A1, A2, A3, A4, taking from right to left. And similarly, the second number is B1, B2, B3, B4. These are the digits. Okay, and these two numbers are to be added. Okay, and suppose to this A1 already some carry is input. However, initially it must be 0, but suppose in general I am taking a case that already some carry C1 is input to these first digits. Okay, so how we do C1 plus A1, and then whatever the result is, that is added to B1, and then this is the final result, and this is the carry C2. This C2 is added to A2 and B2. This is the final result Y2, and suppose this develops carry C3, then C3 is added to A3 plus B3, giving the result Y3, and overall carry C4, and like this. Ultimately, C4 is added to A4 plus B4, like this, and here it ends. Okay, so in case the carry is developed in this case, then one more digit will come. However, I am taking Y1, Y2, Y3, Y4. Okay, now the principle is that C2, C3, and C4, these are the carries. This is the first carry, suppose C1, and C2, C3, C4 or further carries are actually a function of only C1. Okay, so by the help of only C1 that I will show you, and some more hardware implementation, we can fastly develop C2, C3 and C4, which can be added parallelly. Means A2 and B2 will be added. There is no wait of formation of C2, C3 and C4. They are formed simultaneously and added to the digits. How? See, this is the first full adder to add A1 and B1. So this A1 and B1 are input to this SOR gate. Okay, and this will add the two numbers, as well as this A1 and B1. The input is supplied to an AND gate to develop the carry. Okay, similarly, when A1 and B1 are added, ultimately the output is coming out. So that is added to the carry by the help of one more SOR gate. Okay, so that will give the output Y, and the carry developed by the help of this addition of A1, B1 and C1. We have to input it in another AND gate, so I will get the carry. So out of these two, only one case will develop the carry. So either this or this. So applying an OR gate, so this is the C out that will give out C2. Okay, so how we can develop the mathematical function of this C2? Simple, carry is developed by the help of this AND gate and this AND gate, and out of these two, any one we have to take, because either this AND gate will develop carry or this AND gate, so it is supplied to an OR gate. Okay, so for this AND gate, the expression will be A1 dot B1. Okay, similarly for this AND gate, input to this AND gate is addition of A1 and B1. Means after passing through this SOR gate, this X is A1 SOR with B1 and dot C1. So this is the expression of this second AND gate. Okay, so out of these two outputs of these AND gates are passing through this OR gate. So for OR gate we have to apply plus sign. So the carry which is coming out from this first full adder is equals to A1 B1 plus A1 SOR with B1 dot C1. Okay, so this is the C2. Now going ahead, so here the next digits are B2 and A2. So they are added by the help of this SOR gate. So the carry developed is how much? That is equals to the AND of B2 and A2. So similarly, the carry developed by the input carry plus the addition of this A2 and B2 is by the help of this AND gate. So that will be what? A2 SOR with B2 and dot C2, and both are entering an OR gate, so we have to apply plus sign. So C3 is this. Now what happens, that we know this C2 already has a formula this. So in place of this C2, I can keep this entire function. So in place of C2 I have written A1 B1 plus A1 XOR with B1 dot C1. Now what we see over here, that C3 is depending on this mathematical Boolean expression, in which the only carry it is depending is C1. Okay, C2 is depending on C1, as well as we have brought C3 also depending only on C1. Similarly, this C3 is going to the next full adder to form C4. From this full adder, C4 will come out. So C4 expression will be, see, B3 and A3 are next digits to be added. So B3 and A3 ended. Similarly, the addition of this B3 and A3, that is X. So that is equals to A3 XOR with B3 and ANDed with C3. So dot C3. And both are, the output of both the AND gates are passing through this OR. So we have to apply plus sign like this. So C4 equals A3 dot B3 plus A3 XOR B3 dot C3. Now, C3 expression we already know, that is this A2 B2 A2 XOR with B2 dot this A1 B1 plus A1 XOR with B1 dot C1. So in place of this C3, I can write that entire expression. So when I have written the entire expression of C3, what I am getting, this long expression which contains only C1. So C4 also only depends on C1, you can see. So all the carries are only depending on C1. You can see C2 depends on C1, C3 ultimate only depends on C1. Similarly, C4 also depends on C1. So what the change is that we have to apply some more hardware in this case. You can see for implementation of this Boolean expression, some more hardware has to be applied so that we can add the carry bit simultaneously with the addition of the digits which are to be added. Okay, so hope by this small lecture you would have understood that what is the principle of carry look ahead adder. Thank you.